So many of you will have met Julian Seidenberg, and I've also had the privilege to work with Julian. So I've seen the depth and the breadth of his skills, and he's also an industry veteran with a couple of decades of experience in academia and industrial AI. So please join me in thanking Julian very much for giving us his time tonight.
Thank you, AI Jordan. All right, welcome everyone to this Meetup discussion and talk on best practices and tips for LLM application engineering. All right, so overview of what we're going to talk about. First of all, some foundational knowledge, some basics, so we have the terms of reference to talk. And then 11 techniques to improve GPT or large language model responses in general. And then some ecosystem and non-functional considerations, what libraries to use, how to deal with cost, and so on. Conclusions, a topic of what might interest you for future topics and future meetups, and questions, of course. Let's get started with the foundational knowledge. All right, who feels like this? Yeah. Yeah, everyone. It's definitely like you have a fire hose of AI news pointed at you. Every day there's some groundbreaking announcement that comes out that's going to change the world. How do you cope with all this information coming your way? For myself, I struggle with this. I've kind of figured out how to survive the flood of information. And it really comes down to, first of all, a news aggregator, something like TLDR AI, that twice a week it sends you a summary of all of the important AI announcements that have happened since then. And you can browse the email. It takes about, 5 minutes to read the email in your inbox, and you kind of know what's going on. So that covers the what. And then more important than the what is the why. Having a deep understanding of, does this matter? And if so, why? And how can I put this into perspective and integrate it into my own knowledge? And for that, I listen to the Machine Learning Street Talk podcast, which is like super academics who discuss these things in hour-long podcasts. It's really deep, it's really technical, but I find it very useful. Might be too
Excuse me, Julian, sorry to interrupt, but will you be able to share these slides with our members after the presentation?
Of course, I will.
Fantastic. So none of us need to frantically scribble down these different podcasts. That's great. Thank you.
But yeah, feel free to take pictures if you want. Don't mind. Yes, I will be sharing the slides. So that helps understand the why and the deeper understanding and integrating this into knowledge. So that helps me cope with this fire hose of information. I basically ignore any AI article I see, because if it's important, it'll come through the news aggregator. And then I can place it into its level of importance based on my understanding. Is this just a product announcement, or is this something actually useful? So let's start with the basics. What is GPT? The generative pre-trained transformer. Generative, it generates text. Pre-trained, it comes pre-trained out of the box. You don't need to train it yourself, unlike traditional AI models that you might need to train yourself. And it's a transformer neural network model, meaning it uses the transformer neural network architecture that Google invented in like 2017, I think, which is able to learn any pattern that is been given. It has no inductive bias, meaning it's not biased to any kind of learning. It learns whatever you give it, whatever training data that you give it. That is the technical explanation in what GPT is, and it's very aptly named, very technically named. So who would agree, yes, it's a next word predictor? Yes? It predicts the next word, right? Yeah, it's an enormous transformer neural network. Big neural network. Yes? Yep. And you could argue that it's a lossy compression of all the text on the internet. They've taken all of the text on the internet, shoved it into this thing, and can kind of reproduce stuff. Sometimes it gets it wrong, but overall it reproduces text that it's been fed when you ask it questions. Yes, all these things are right?
It's like WinRAR, except people will actually pay for it.
Yes. It's a WinRAR, the compression library. No, it's none of these things. It's far more subtle than that. No, it's not a next word predictor. It's beam search. No, it's not an enormous transformer neural network. It's a mixture of experts. And no, it's not a lossy compression. It's not WinRAR. It has actually learned to think. And when I say it's learned to think, some super academics like Noam Chomsky and Jan LeCun say, no, it hasn't learned to think. It doesn't know how to think. Noam Chomsky specifically says, LLMs have accomplished nothing. Nothing, I tell you, nothing. So he's very passionate about LLMs being complete hype and not worth our time. Jan LeCun is a little bit more moderate, but he also says, no, LLMs do not think. So this is a contentious statement, but I can argue that they've kind of learned to think. Think in the sense that instead of compressing information and just reproducing compressed information, if I ask you what is 5 plus 7 plus 350 plus 209, you could memorize the answer to that, or you could learn to think and reason, learn the math formula and reason it out. It's far more efficient to learn the formula than it is to memorize every possible answer to every possible math question. So similarly, GPT has not learned to memorize every answer to every question. It's learned the pattern, learned the reasoning pattern it needs to get from a question to the answer. So in that sense, it's actually been forced to learn to think because the thinking process is the most efficient way to learn how to produce the next best word to an answer. So then, beam search. Why is it not just a next word predictor? What is this beam search? What is it actually doing? It's not just predicting the next word. Instead, GPT, when you ask it a question, predicts the next couple of words in a tree. So it goes you input the, and then it goes, well, the next word could be dog, could be nice, could be car. Let me predict all of them. And then, okay, if the next word was dog, the next word from that is and, runs, and has. And each of them have a probability of that being the most confident that that is the correct next word. And so it builds this whole tree that expands out of the whole tree of probabilities of most likely next word. And then it runs a search across this tree to find the overall tree path that adds up to the highest probability percentage. So you could start with, in this example, dog is slightly less confident, at 0.4, than nice, but has is much more confident than woman in that sense, in that example. So overall, even though dog is a lower probability next word prediction, it will go with dog because has is a higher probability in the end. So it, much like when I think of what I'm going to say next, I don't just think of the next word. I think of the whole phrase and where I'm trying to get to when I'm speaking. So therefore, GPT is doing the same thing in this beam search, where it's searching that tree of all possible next words, several words ahead, to come up with the best phrasing. So no, it's not just predicting the next word. It's far more clever than that. And next is just an enormous neural network model. We see GPT size increasing by an order of magnitude every couple of years. GPT-5, people are speculating, will be in add another 0 to that. We'll see. Up here. And they're increasingly becoming more expensive to run. And no, again, it's not exactly, it used to be an enormous transfer neural network model, but now GPT and any successful large modern large language model is what's called a mixture of experts. Instead of being one enormous unified neural network transformer, it is several, 16 plus, no one knows exactly how many. It's broken down into several experts. And when you ask it a question, the first thing that happens is the question is analyzed by a gating neural network that goes, which expert is best at answering this question? And then it will turn off parts of the network and redirect your question to only the parts of the neural network that are relevant for answering that question. So if you ask a Python programming question, it does not have to invoke the entertainment and gaming expert that you might ask it if you're asking about a movie. And if you're asking about a movie, the Python coding network has nothing to do, so it's completely turned off, which is why GPT-4 Turbo is much faster than GPT-4. It's no longer running the whole network. It's only running maybe a 16th of the network. And a 16th, if you divide 1,700,000,000,000 by 16, you end up with something that's kind of GPT-3 size. So most questions you ask the GPT-4 and Turbo are actually small, are running on a similar amount of neural network nodes as GPT-3 would consume. So that's why their GPT-4 is relatively cheap and is possible to run cost effectively. So no, it's not an enormous neural network. It's this mixture of experts. And if you're aware of this, it's very important, and I'll get to this, that we ask GPT the right question so that this gating network can figure out which expert to invoke. If you invoke the wrong expert, you end up with a very bad answer, because the part of the neural network that can answer your question is not running. All right, let's start with the basics of asking GPT questions. Basics of prompting. You need to give GPT an identity. You need to give it an instruction. You need to give it a style, example, perhaps, if you want. And you need to give it context, most importantly. Here's an example of that. You're a professional plumber, identity. Write 3 sentences describing nuanced standard operating procedure of how to install a new sink, instruction. Write in a professional style with small elements of rhythmic jazz poetry style. And context, the house is built in the 1920s, New Zealand, wood walls, no insulation, has low water pressure, typical in New Zealand. So then it comes up with an answer. I won't read it out, but it fulfills that pretty well. Here I haven't given an example, but we'll get to that. All right. Onwards. When GPT is generating information, generating text, it's generating not every letter at a time. It's generating tokens. You might have heard of GPT generating tokens instead of letters. And tokens are not words. Tokens are parts of words which have a corresponding number. And all GPT is doing is taking these numbers, taking the number representation of the words that you're asking it, and spitting out numbers that correspond with that. So every word in English or a part of word is represented by some number in GPT, in the token representation. I think GPT-3 had about 50,000 tokens. GPT-4 has many more because they've made it understand every written language in the world. So there's a whole bunch of specialist tokens for various languages in the world. So the cost of GPT also comes down to how many input and output tokens you give the model. And you might think, wow, what? And that's pretty long. That's going to cost me a lot of money. What if I shorten that into that? It's like half the length in terms of letters. That'll save me a lot of money, right? No. You shorten it. The things that are not words need to be composed of lots of smaller tokens. So therefore, you actually end up with 13 tokens instead of 11, even though the number of characters is half. So best give instructions in full words, which consume actually less tokens than maybe stringing individual letters or identifiers together. Don't write Unix commands, write full sentences. All right, with that background knowledge out of the way, let's go into some techniques to improve the output of GPT, so-called prompt engineering. Let's go through 11 of them that I have used. Question there?
Should we ask a question?
Let's save them to the end if you can remember, unless there's something urgent that you want. No? Okay. All right. So 11 techniques to improve GPT responses. I have used all of these myself, except the last one. So these actually work. First one, use a test set. The amount of times that I've spoken with software developers who are like, I've improved the model. look, I've changed the prompt. I've changed what you asked the LLM, and it gives a better response. And I'm like, have you tested it on the test set? And inevitably the answer is no. But yes, you might improve. So this is the intersection of engineers can now do data science. Data scientists have drilled into them from early university days that in order to validate anything, you need a test set. You need to break it down into a training, test, and validate your model and give a statistical answer for how well your model performs. With large language models, you can kind of get away with skipping that. But you put yourself in a lot of danger because modifying the prompt might improve one particular answer that the large language model gives, but it might break 10 others, and you don't know unless you test it in the test set. So then your question is, well, that's okay if I'm using GPT just to kind of predict a category or do something reproducible, but what about if I'm generating some text? How do I know if that free-form answer that's different every time is the right answer? So here's what I would do. I would write the ideal answer for some representative data set. Then I'd ask GPT the question, providing context, instruction, and so on. And then I'd use GPT itself to evaluate its own performance, where I modify the prompt, I run through the 300 examples, and then for each of the 300 examples, ask GPT, does the answer that GPT gave match the ideal answer that I gave? Close enough? And then GPT can score itself to generate an accuracy score based on how close its answer is to the ideal answer that a human has written. And then you can modify the prompt and continue to improve. All right, next one. Say sorry. My son used an AI generator to generate this picture. He wanted me to call him out in this talk. So kudos to him for creating this "sorry, I don't know" phrase. Sorry, I don't know is one of those magic words that you can use in GPT to make GPT say when it doesn't know the answer instead of hallucinating some answer that it sounds right, but is completely wrong. The reason why "sorry, I don't know" works is that sorry is a very specific word in English. You wouldn't normally jump to sorry when you're predicting a next word or even a whole phrase of next words. Sorry is used in super specific context. So if you're asking it to classify between cats and dogs, sorry is not going to, it might accidentally go elephant, but it might not accidentally go sorry. It'll never accidentally get to that. So by telling it, if you don't know, say sorry, it will jump to that very reliably rather than kind of accidentally ending up there in the randomness of the GPT response. So any classifier you build with GPT, including a phrase that says something like, if you don't know, say sorry, I don't know, you will get better responses in the cases where GPT is unsure about itself. All right, number 3, invoke an expert. We talked about this before. The mixture of experts is GPT. This didn't used to be so much the case with GPT 3.5. It's not the case. It's one unified model. Now GPT-4 Turbo is a mixture of experts. So you specify the expert. You are an expert librarian. You are an expert cook. You are an expert, you're an expert software engineer. So depending on what identity you give GPT for answering your question, it'll be able to do a much better job. If you ask it a programming question and say you are an expert movie critic, it will do a terrible job of trying to answer your question. And somewhat more advanced technique, you can invoke a panel of experts. Why just stop at one? You're a panel of 3 different expert theoretical physics professors. The first expert is this, and you specify the biases of the experts, come to a consensus conclusion using the best idea from each expert. What percentage of research funding should go towards string theory? You can ask multiple experts, and I tried this. It creates a skeptical expert, a creative expert, and a practical expert. And they each give different percentages and come to a conclusion of 20 to 25%. If you just ask this question straight up, it might not get to such a good response as if it combines the answers from multiple experts. Okay, number 5. Moving right along. Few shot examples. Giving examples greatly helps GPT answer questions. You could ask it what's called zero shot, when you give no training data at all and rely on the inherent knowledge of the model to answer the question. Or you can do few shot learning. One shot if you give one example, or few shot where you give just a couple of examples. In this example, expert librarian click classify text into finance, technology, environment, or sorry, I don't know. And scientists discover a more efficient way to convert sunlight into energy. Is that environment or is that technology? I tried it. GPT says technology. So the examples greatly help GPT understand. It used to be, back before GPT came out in the dark ages, a year and a half ago, to do something like this, you had to train a BERT model, and you needed like at least 10,000 examples, probably more like 100,000 examples to make this work at all. And now you give 3 examples and GPT is like perfect at generating the right answer. It's amazing. It reduces the cost of doing this kind of machine learning classification by several orders of magnitude. It makes it so much quicker. But the examples definitely help, and clear examples help, as well as if you want JSON output in a machine readable form. JSON mode used to be terrible in GPT. It would take forever to run and give inconsistent results. They fixed it recently. And you could specify a parameter when querying GPT to say, give me JSON. And then you could also need to say that in the prompt, in the system prompt. And if you do those 2 things, you get nice, reliable JSON output relatively fast from the model. So it now works. So I tend to do this because JSON is just easier to do than writing some kind of parser to understand the answer. All right, moving along. This is an advanced technique, the logit bias classifier. If you want to turn GPT into a classifier where you're doing something like this, where you're classifying between things, and you want to make it as efficient and accurate as possible, you can use this trick that Adam Azam figured out and posted on Twitter, X, whatever you want to call it. To do this, the logit bias is a parameter that you can set when calling GPT that biases which output tokens are more or less likely to come out of the model. If you specify 3 output tokens, 3 numbers, and set them all to 100, the GPT can only output those 3 words that are represented by those token numbers and nothing else. So if you do that, and those 3 words happen to correspond to happy, sad, and mad, as in this example, it can only output those, and it can invest all its smarts into coming up with the best one of those answers. So in this case, and it's much faster. If you only allow it to output 1 word, and one of those words has to be one of those 3, in this case, in this example that he used to validate this, it went from 14% accuracy to 84% accuracy, and the speed was half the speed, or twice as fast to get to the answer in doing this. You can look it up. It's a somewhat advanced technique because you need to work out what the right tokens are, which correspond to your classification categories. But once you get that running and you specify the logit bias of which tokens you want to input, it doesn't take too long to code this up. You can get an amazing classifier if that is indeed what you want to do. If you don't want it to generate text, you just want to decide between different categories of what you want to input and output. I've used this. It's great. All right. Number 7, self-reflection. Apparently, this improves coding tasks and other kind of complicated things by 20%. If you do this, you can use various phrasings to do this. Is this the best answer? Is this the simplest possible? Have you considered all the edge cases? So GPT gives an output, and then you ask it a follow-up question. Are you sure about this? Could you improve this? And then it goes, oh yeah, actually, thinking about it, I could actually improve this. And you get, is that all you got? Can you improve it again? And you keep self-reflecting a couple of times, and GPT will gradually arrive at a better answer by you kind of prompting it to coax it into a better situation. Of course, if you're doing this in a production app, it will take correspondingly longer to get a good answer, because not only do you have to call GPT once, you have to call it twice or 3 times to get it to self-reflect. So it might not be worth it in a production context, but self-reflection does often get GPT into a better response. All right. 8, chain of thought reasoning. So this is the magic phrase, let's think step by step. University has tried a whole bunch of magic phrases to help improve the response from GPT. And let's think about this logically. Let's think, it's a beautiful day. Don't think, just feel. Yeah, GPT does terrible if you tell it, just don't think, just feel. But let's think step by step is the magic phrase that is best at invoking a chain of thinking. Just like GPT needs space to think, and it thinks best by, or I'm using quotes here, where think in its sense of thinking, not in our sense of thinking. Thinks best by speaking out loud, by writing out loud. Instead of, if you ask it a complicated math question, instead of trying to jump directly to the answer, which will most likely be wrong, if you say, here's the complicated math question, let's think step by step, we'll go, well, to solve this problem, first of all, we need to do this and this and this. And then the first answer to this is this. And then it spends a long time talking its way through. And then at the end of all of that, generated text, the previous text, which is using for reference to produce the next text, leads it to infer the right answer. So this works extremely well, but also, of course, produces a lot of text and takes a long time when you tell it, let's think step by step. Modern large language model developers are like poet magicians who have these magic phrases that they can, these magic spells that they can invoke by saying, ask this question and let's think step by step, and suddenly it works. You've cast the right magic spell with the right words. You're like a bard in Dungeons and Dragons. So there's a reference to the paper. You can reference it when we send the slides out. And for really complicated questions where its own let's think step by step is inaccurate, you can give few-shot examples to teach it how to think about the problem. So if you ask it something novel that it's never encountered before, you can say, well, think about this problem like this. Here is an example of a similar problem, and here is how you would think about, here are the steps you would take to reach an answer. And then it can reproduce those steps and usefully answer a question. All right, next. Moving right along. RAG. Of course, this is all the rage. All I see in my LinkedIn feed is like RAG, RAG, RAG. Everyone's talking about RAG. Retrieval augmented generation. And this is great for reducing hallucinations, reducing false positive responses where the LLM answers confidently with a wrong answer. This is also great for getting truthful information from enterprise knowledge that's not out there on the internet, that's locked away behind some proprietary data source. It reduces the cost of Google came out with Google Gemini, which apparently can have 1 million tokens as input context, which is huge, but also really expensive if you input 1 million tokens into this large language model because they have to process all of them. A RAG is a way of reducing even if you have the space in the large language model to input a large amount of information, with RAG you can input a smaller amount of information and get a useful answer. And can provide provenance, so it can link its sources, it can reference its sources. So rather than just making something up and you hoping and trusting that the large language model gives the right answer, you can ask the large language model to say where has it based its information from, which also helps with the truthfulness. And how this works, briefly explained, is you ask a question, then you encode the question into an embedding, which is a number about, what do we have now? About 1,500 numbers, which represent the semantic meaning of the text. You have an axis in multidimensional space for every type of meaning. Like you might have an axis for royalty. So king and peasant are on opposite ends of royalty, you might have an axis for gender, where male and female are on opposite ends of the number. So like -1 might be female, +1 might be male in that axis. And so this, you can imagine somewhere in 3-dimensional space, you can use a GPS coordinate to say where you are in space and up, down. You can similarly place a phrase of text somewhere in this higher dimensional space of 1,500 dimensions. And then you can compare, is this question's position in space close to the position in space of all of my internal text in my enterprise knowledge base? And then you take the closest, nearest neighbors to your question from the enterprise knowledge, look up what the corresponding text is, give that text as additional background context in addition to your question to GPT-4. And this GPT is then able to use information in that text to answer your question rather than having to make up the question from its own internal knowledge. And it works pretty well as long as the text that you found by a vector search is relevant to the question. The problem, though, is that this relies on the vector search and vector database to be correct at looking up the most relevant information. It's doing a similarity match on the meaning of your question and the meaning of the text in the database. And that is not nearly as smart as GPT is at finding relevant information. You might ask something that seems relevant to one topic, but is actually related to a completely different topic that is nowhere near the same relevance in the vector space. So you can get GPT saying, sorry, I don't know, when actually the information was there because the vector search didn't find it, didn't reference it, because it's not in the same space in the database, in the multi-dimensional vector space database. So this creates the opposite problem to the hallucination. It creates a false negative instead of a false positive, where it gets, I don't know, don't have the answer to this, even though it does, and it could have if it had looked up the right information. That fine-tuning, you can create your own GPT neural network. This currently only works with 3.5, and you do this by GPT-3 and 3.5 are apparently 96 layers of transformers, neural networks stacked on top of each other. And it takes months, of course, to train this. But if you lock most of the neural network and only take the topmost layer, you input the text at the bottom, it goes up, gradually generating the response. And if you only train the topmost GPT encoder layer, it's 96 times faster to do that, actually more than 96 times, because you have to go through all the layers for every training run. And so it's orders of magnitude faster to do that. And you don't need to store this giant neural network. You only need to store the changes to your final layer, which is relatively efficient to store. So train your own variation of GPT that is trained on your specific data set or your specific set of questions. And then GPT becomes better at answering those questions than out of the box GPT. So many companies that have specific needs will train their own GPT classifier, and it performs well for that need and is faster and cheaper than using GPT-4. I find fine-tuned GPT-3 versus well-prompted, few-shot prompted GPT-4, it's kind of a wash. You're getting similar results depending on what you're doing. For some specialist cases, of course, you would want to go with fine-tuning. Problem with fine-tuning, of course, that it suffers from hallucinations, false positives. It will make stuff up if you ask it a question. I saw an article from LexisNexis, who are like they have like every legal court case that has ever happened anywhere in the world in their database for lawyers to look up. They implemented a large language model, guru type AI that you can ask a legal question, like what happened? Can you tell me any relevant cases to my to this legal problem I have. And people tried it, and they were complaining that, hey, it's making up cases that don't exist. It's inventing cases out of nothing. Most likely, that's because they fine-tuned a model, and they didn't use RAG. They didn't use retrieval augmented generation. They used the fine-tuning model, which is the wrong approach for looking up legal information. And so I don't know why they did that. Maybe they started their project before RAG became popular. But yeah, fine-tuning has its place for certain approaches, but be careful about using it in place of RAG or instead of RAG. However, what about RAFT? Retrieval augmented fine-tuning. It's basically combining fine-tuning and RAG together. So you fine-tune a model and you run retrieval augmented generation using that fine-tuned model, which kind of combines the best of both worlds, and you can add in chain of thought as well. So it reasons its way through the answer. So you're combining all these things together. Microsoft Research just this week released a paper explaining how to do this and saying, in theory, it gives good results, but every use case will matter. For something really important, this is worth trying, of course. All right, that's all 11 tips that I had for improving large language models responses. Now some more meta discussions, ecosystem and non-functional, nearing the end of the presentation here. First of all, accuracy versus speed and cost. I don't see anyone talking about this online. It's super important. If you implemented every technique I just outlined, all of those 11 techniques, you can easily get to 10 cents per query in your GPT API call. Maybe 7,000 input tokens, 1,000 output tokens as it's doing its chain of thought reasoning, 7,000 input tokens if you give it a lot of context from your RAG search. So you better, and take 20 seconds to answer your question as it's outputting all these tokens. So you better have a use case where the value you provide to the customer is worth the 10 cents per query that you're spending, or significantly more than 10 cents per query that you're spending to give the customer the answer. And for many use cases, this doesn't make sense. The value that you can derive, especially if you have like a freemium advertising model to your app, you're not going to make that amount of money from your customer to justify the cost of doing all of this advanced LLM mechanics. So many startups have these cool demos, which look amazing, seem incredibly useful, but just can't make any money off them because they're not providing enough value to their end user to make it economically worthwhile. And I don't see anyone talking about this. So there's a whole bunch of LLM-based startups that are just destined for failure because they are not operating in an industry where the value to the answer to the question that they're providing justifies the cost. Yes, GPT is getting cheaper as it's getting more optimized and so on, but not fast enough for most use cases. And most users will not want to necessarily wait for 20 seconds to get an answer, unless the answer is extremely high value. And we find at my work that sometimes we want to go back to a traditional classifier that we can run really fast, we can run in milliseconds, for something that is high value, and we want an immediate answer for the user. So all your traditional NLP knowledge is not out the window just yet. It has its use and it has its time and place, particularly for things that are low value and latency dependent, where you want a fast answer for cheap. Building your own classifier might actually be the right solution, especially if it needs to be run at scale. All right. Next, replace or augment. This is also something that I don't see people talk about. People are afraid of GPT will take all my job. Well, let's not be like all or nothing. Or like, I'm not going to use GPT. It can't do my job. GPT can never take my job. It's so complicated. So you get both extremes. But what about everything in between? So at the start, you have fully human tasks that require full human intuition and are not currently being able. Large language model currently can't do them. Those tasks exist. Then if you go one step further down the LLM path, a human task that the AI monitors and suggests, hey, well, maybe you could have done this better this way. Maybe you made a mistake here, and double check this. Very helpful for safety critical tasks. And the LLM can come in and go, hey, are you sure? And then a human task that the AI assists maybe can handle half the work, write something for you. The AI task that is then always checked by a human. The AI completely finished the task, but there's a human in the loop who always checks it and approves it, going, yes, this is correct. This is correct. Go, go, go. And an AI task checked by the human if the AI is unsure. If you can generate some kind of confidence score from the AI, which is somewhat hard to do with a large language model, but can be done, where you ask it to rate its own confidence, maybe self-reflect on itself. Are you sure about this? If it's at all unsure, defers to the human to confirm those, not every task, but the ones that are unsure. AI task with human oversight. So AI runs tasks, human occasionally does a spot check review. Was this answer correct? Do we need to tweak anything? And finally, a fully automated AI task where AI completes the task from beginning to end with no human intervention. Where you build on the spectrum depends on how good the AI response is. And you might place yourself anywhere from 1 to 7. And it's not an all or nothing situation. And it's very important when designing how the AI interacts with the human in the automation space. And yes, which LLM do you use? GPT-4 is not the only game in town, of course. This LM Sys Chat Bot Arena leaderboard is it basically does Tinder for large language models. It shows you asks you to ask a question. Well, it doesn't show you the name, generates the answer with 2 different large language models, and asks you to rate which is best, swipe left or swipe right on this LLM on the 2 responses. And then based on actual humans, in this case, 400,000 people have played the game and rated responses, it creates an ELO score for which large language model is best, wins the most contests. And yes, GPT-4 Turbo is best, certainly, proven by actual unbiased users, seeing the responses and consistently rating it highly. Anthropic is a close follow with their Claude model. Google's Gemini Pro Bard is in the running pretty good. They've caught up. And then if you go down GPT, Anthropic, Minstrel's the large model. Minstrel is this French AI company. I looked them up. They basically hired every French, smartest people all over the world who speak French, who are working in AI. They all work for Minstrel. They shipped them all to Paris. And they created this really competitive, world-leading large language model, which was really impressive. They came out with something so good. It's a mixture of expert model, just like GPT-4. And then there's a couple of others. Alibaba has one that's pretty good. And then right down the list, Llama is very bottom of the list. Meta's model, Meta's 13 billion Llama model is the very worst of the large language models currently. Other models, like the larger Llama model, it's more intermediate. But yeah, Meta will probably release like Llama 3 soon, and it'll be up at the top again. But so in terms of which large language model do you want to use, well, look at the leaderboard and pick one near the top that maybe fits your specialist use case. Some are open source. The open source models tend to be lagging behind the closed source models because the closed source companies have more money to deploy to collect more training data, more GPUs, and so on. But it's a good resource to see, and it's an unbiased source of information. All right, which library to use? It's really a game between LangChain, open source LangChain, and Meta's Llama Index, and they're both useful for different purposes. I find that LangChain in the name is great for chaining multiple responses together. You might want to do a panel of experts, not in a single query, but as multiple queries that you run concurrently and then join with another query. LangChain is great for that. It's also great for reasoning for that same purpose, where you ask it a question, ask it to reason about its own question, this kind of self-reflection stuff. And it's great for if you want an abstraction layer where you instead of it gives you kind of classes and objects, so you can put your prompts in classes and assemble them dynamically and stuff like that. So it's helpful for just a large application where you're running we have a lot of different things that are interacting with one another. Llama Index is great for retrieval augmented generation. It has great inbuilt support for supporting these indexes. Indexing, search, it's really good at that. It's also good at optimizing itself, where you want to test all this stuff about a large language model checking its own answer. That Llama Index helps you with that kind of stuff. They can do everything that each other can do to a certain extent, but that's a good way to think about which to use, and you can use both together. And finally, are large language models eating the world of AI? Yes, they are. They certainly are. Image vision, GPT vision input. Yep, GPT can now become an image classifier if you want to spend a lot of money. Speech to text. Yes, the Whisper model that OpenAI kind of quietly released a year and a half ago, that uses a large language model in the speech transcription model to guess what you meant to say, even if you didn't actually say those exact words. So speech transcription is now much more accurate than, say, Siri on your phone. The reason your phone is not as accurate is that a large Whisper model is quite big and cannot run efficiently on the phone yet. Wait a couple of years and phone GPUs will be fast enough to run much larger speech transcription models. But for now, cloud speech transcription works incredibly well, amazingly well at understanding you. Time series classifier. There's a mode in GPT-4 where you can turn it into a time series analysis tool, and it does time series analysis. Named entity recognition. Spacey, which used to be the leader in named entity recognition, now has a mode where it basically just calls GPT for all its named entity recognition. Also taken over. Text classification, we already talked about. Writing code, of course. And finally, prompt engineering optimization. If you're currently a prompt engineer who's specialized in optimizing how you ask the question to GPT, there's this framework called DSPY, Declarative Self-Improving Language Programs Pythonically, kind of a convoluted acronym, that for a lot of money in GPT calls attempts to, if you have a validation data set, attempts to automatically optimize your prompt so that you get the best possible answer to your questions in your validation data set. So LLMs are indeed intruding into all areas of AI and gradually taking them over. And with that, some concluding remarks. First of all, follow me on LinkedIn. I will post probably a link to the recording when it comes out. I'll post the slides, as well as, of course, Jordan will post them from the meetup. So GPT has certainly forever changed the world of AI. When GPT came out, it revolutionized the world of AI. Nothing's the same, but it's also really anyone's game now because it's so new. You don't have to be an expert in AI who's spent their whole life studying AI. Anyone can use this with just a little bit of knowledge and build really complicated, sophisticated AI applications themselves without needing to be the world expert. So it's democratized, it's equalized the use and application of AI to a great degree. You don't have to replace humans. You can if you want, but far more useful than replacing humans in many use cases is augmenting them. GPT might not be perfect in every use case, but if you augment instead of replace and take that mindset, GPT can do a lot of useful things and do a lot of improve a lot of tasks. Validate using a test data set. For developers, this is a foreign language. For data scientists, it's a no-brainer, but create a test data set. Even though it's painful, even though it takes a lot of time, relatively, you will save yourself so much effort in the long run by having that test data set that you can always check your answer against. everyone needs to learn some amount of prompt engineering until DSPY makes even that obsolete. But the basics of prompt engineering are useful for anyone. All those English skills that people thought by studying computer science, you don't have to be good at English. No, the world's come around again. And you're back to needing to understand English and the magic phrases, magic spells you need to cast to make GPT do your thing. And consider the non-functional requirements of cost and speed. As don't attempt to do something if the economics will not work out in your favor. Analyze that before you start, not when you're shipping into production. And this is only just the start of the journey. Who knows what will happen? Get used to the fire hose of information coming your way. This is an interesting time to be alive and be in this tech space. Let's see where this all leads. Thank you very much.
Cool. I had a question. You were talking earlier about the different layers of applying, I guess, large language models. And in one of the steps you spoke about having not necessarily the human in the loop, but having the machine ask when it's unsure. I was just curious about your experience having done that, or your intuitions toward where the LLM may or may not be able to correctly interpret where it may or may not understand.
Yeah, it depends on the task. If you ask it if you ask it a coding question and then ask it to reflect on itself, it can do a great job of kind of spotting its own coding mistakes. If you ask it a kind of general trivia question, where like if you ask it a question of how do I do this? How do I diagnose this? If it gives the wrong answer, and I find no amount of coaxing can get it to the right answer, and then I look up the right answer and tell it, and it's like, oh yes, of course, yes, that is a good answer. And you're like, well, why didn't you think of it? It kind of answers. It's like, well, I don't know. Makes up, gaslights you with some excuse. But yeah, it really depends on the application of where self-reflection works and where it doesn't. Yeah, so does open source make sense because you can potentially save some costs? Not really, because you can run an open source large language model on, say, AWS or Azure in a cloud service where it kind of makes sense. If you want to host that yourself on your own computer or on a server that you rent, you have to pay for that server even when it's not being queried, where with GPT, you pay as you use. You pay for every query. So for a startup, just getting started, not having a lot of users, the model of paying per query is much better because you control your costs as they grow with your users, rather than having this fixed cost all at once that you have to pay regardless of whether it's being queried or not. And the open source models are not as good as the proprietary models. So you're using a worse large language model, which might not be able to do the task as well. So in both cases, I would not recommend going open source unless you have a specific requirement that, for example, need to run offline, where you just buy a high-powered GPU server and put it in a box somewhere, and you're running it offline. I don't know, in space, underground, where you don't have internet access. Or if there's high security requirements where the data can't leave the local network. So in that case, yes, an open source model does make sense.
So most of this presentation, you mentioned asking questions. Do you just mean that because you're asking questions to the LLM, or is it just the phrase you put it, or would you always actually ask questions, or can they be in other forms?
Oh, well, large language models pre-ChatGPT 3.5, or before 3.5, there was this GPT-3 Instruct GPT model that came out. You used to have to ask them questions. You used to not be able to ask them questions. You used to have to phrase something and then let it complete your sentence. So the quick brown fox, and then you stop, and it jumped over the lazy dog. So it completes your sentence. And if you asked it a question, it couldn't answer. It would just go crazy. Since then, with the way that large language models now are trained, using what's the word? I forget the particular, but yeah, reinforcement learning with human feedback. Thank you. The training data to take the raw text completion model and turn it into something that can answer questions was specifically written in such a way that it's question and answer format. So it used its ability to predict the next word to now fine-tune that into a model that is able to answer questions and follow instructions. So instructions work. The other thing still works also, where it just completes text. But I find the question format is just a lot more approachable, and it's much easier to fine-tune as well. If you want to fine-tune a question and answer in that format, it's much easier than fine-tuning this and this is the completion.
Thank you, Julian, for such an in-depth and well broken down talk. Perhaps you could explain your experience of and your vision of AI agents. It seems as if the AI has agency, the impact it can scale much larger.
Now, in theory, GPT and large language models would be great to create a kind of autonomous agent that can make a plan, criticize its own plan, then write the code to execute the plan, then run the plan, and get the result, look at the result, make another plan on what to do next. So you give the AI a goal, and it works its way to solving that goal by acting as an autonomous actor in the world. And you can imagine all kinds of science fiction horror stories from that going out of control. But in practice, you go down about 2 steps of that, and GPT completely messes up and gets itself into an infinite loop of trying to correct, and it doesn't working, and it gives up after spending a whole bunch of money on prompt inputs. So in practice, I have not seen GPT agents do anything beyond trivial tasks well. That said, OpenAI know this, and for sure they are working on this in GPT-5. So watch this space. We will see what happens. So tips on splitting prompts and why they are charging for input tokens as well as output tokens. The apps. I am not sure on the answer to the first question. My best guess is that if a model has, say, 1 million token input size, you need to basically do matrix multiplication for all of those 1 million tokens that you're running. If you only input 1,000 tokens into that 1 million window, there's a whole bunch of zeros in that matrix math, which are easy to calculate. The answer is 0. So you're running less stuff for your GPUs. That would be my guess, but I'm not sure. Don't know if anyone else has any insight on that. Nope.
Don't they have to reparse the text that comes before? But it's all kind of, is it?
Oh yeah. Yeah, and then for every single word that they generate, the entire input of those 1 million tokens plus 1 is input. So it kind of exponentially comes through. For the more output you have, exponentially the computation gets more expensive. And then if you have a large meeting that you're summarizing, or a large text that you're inputting into a model, and you want to summarize them, I mean, yes, you can break it apart and summarize each section independently, and then have the GPT summarize the summaries. In that way, LangChain would be a great way of doing that. You can, of course, use one of these 1 million token models that have the capability to take all of this information in at once. Though, of course, they're more expensive. Other than that, vectorize each paragraph of your meeting transcript and try and answer. If you're asking a specific question, if you have a specific thing that your summary is trying to achieve, then you can do RAG. Or RAG versus fine-tuning and smaller models. Fine-tuning is not changing the input to the model, but changing the model itself. So it has a different inherent understanding in its own memory, where RAG is keeping the model the same and changing the inputs to give it relevant information to help it answer the question. And in terms of smaller models, there seems to be some emergent behavior that when we looked at that chart of the size of various large language models from GPT-1 to GPT-4. I tried like GPT-2 or even GPT-3 when it came out. It was garbage. It was terrible. You could not generate anything useful. Within 3 words, it would devolve to utter nonsense in its response. There's something about, you need a certain minimum number of size of your transformer neural network to get decent responses out of these things. So very small models will be quite dumb and won't have the size and capacity to answer questions usefully. But once you reach a certain kind of critical size, which seems to be like the GPT 3.5 size as the minimum size to do anything useful, and then you can talk about, and do you combine them all? Do you have lots of specialist models that come together in a multi-agent system, or do you have one giant, enormous supercomputer model? And probably the answer is lots of small models that cooperate, but it remains to be seen, because it's also a lot cheaper to do that than run one giant model. Now, there are some kind of 7 billion parameter, relatively small specialist models that are specifically trained to do a specific thing very well. And that works because they're not generalist models. They're models that are trained for a specific purpose and can dedicate all of their parameters for a very narrow range of tasks. So that works also.
But let's just give Julian a huge round of applause for asking our questions and giving such a fantastic, there's so many nuggets of gold in that talk. So thanks so much, Julian. That's fantastic.
You're welcome. Thank you. Thank you for inviting me.
So I've worked on 5 or 6 different LLM applications now. A couple of things I found, I used to do a lot of the datational responses, like asking a model for JSON, and really powerful technique, fantastic. Sometimes I didn't find myself putting in quite a lot of time to like correcting maybe some corrupted JSON it sends back, or it wouldn't quite get the memo about sending the JSON or how it should be formatted. LangChain has a kind of like buried, and again, I'll find the link, module for this where you define the structured output that you want in a certain way, and you provide descriptions of the fields in just the right way, and you kind of go resolve, and it like outputs into the prompt a very specifically formulated way of describing the template that LLMs very reliably respond to and give you structured output, and it parses it for you to JSON and takes care of all the nuances around that. So I found that really great. And yeah, just some of the small, like 7 billion parameter open source models that you mentioned, we can do on-prem. We can host our own servers. You know, like there's lots of documentation out there about how to do that. It all ends about 15 years ago, but that's okay. Like, you know, some of those same Linux flavors and stuff are still out there. You can still create a server with your own hardware. And there are surprisingly good open source models out there. And because there's this mixture of experts, if you only need one expert, there are some where the work these open source teams have done is they've pared down the training set so that it's like just one of those experts in the model, which means that you can potentially only need a CPU. So you don't need specialized silicon. You don't need that much RAM. So you might even be able to afford to just have that instance running in the cloud the whole time, even though it's not being used, if it fits your specific niche. So don't underestimate, that, or what you can do with just like one GPU in a box somewhere if you're a scrapping startup, you know? Getting bad results from vector databases. Often there's like a lot of junk in the results that you can get. There is a class of models called Rerankers, but you can get all the results from your vector database, and then you can kind of like sort them with a model called a Reranker, which can then percolate all the ones that you really want to the top. So yeah, thanks so much everyone for coming. And for everyone who is watching this video afterwards, thanks so much for watching. I'm sure you really enjoyed Julian's talk. And once again, check out VTS who make this possible. Thanks so much again for that. And hope everyone has a lovely evening.